What's up? I'm Vin, and today I want to explore the question, has high school math gotten easier? And to explore this, I want to go in a time machine to January 22nd, 1957, to the advanced algebra regents. And I thought this would be a fun regents to go through because this is a regents that one of my grandmothers could have taken. And we could see here, these are some of the questions, and I'll link the actual test in the description below. But for this particular video, I want to go through question 27. And question 27 here, we'll come up to in a moment, is a work word problem. So let's jump into this. So take a second to read through this. And now let's extract some of this information. So now let's give Bruce, Roy, and John a variable to their name. So with these work word problems, setting up the equations could be a little bit tricky, but we'll just be very careful there. So Bruce and Roy can complete one job in 6 hours, and that allows us to set up the equation. We'll have 6 over x plus 6 over y, and that's because Bruce and Roy are both x and y respectively. And remember, they can complete one job in 6 hours. So we're going to set this equation equal to 1. Now, if that equation doesn't make sense, the way I like to think about these to convince myself that this equation is good is let's pretend for a moment x is equal to 8, which it's not. But in this case, let's just assume x is equal to 8, just in our thoughts. So what that allows us to do is take 6 over x and write 6 over 8. And think about what this means. If Bruce could complete one job in 8 hours, then in 6 hours, Bruce would have completed 3/4 of the job. So this is the idea. And this is going to allow us eventually to solve for x, y, and z. So now we just have to set up 2 more equations. Bruce and John can complete one job in 8 hours. So Bruce is x. So we're going to set up 8 over x plus John is z. So we're going to have 8 over z. And they could complete one job in 8 hours. So we set this equal to 1. And now the last equation that we want to set up here is for Roy and John. So they can complete one job together in 12 hours. And Roy is y, so we're going to have 12 over y for Roy plus 12 over z for John. And Roy and John can complete one job together in 12 hours, so we set this equation equal to 1. So now let's go ahead and solve this system. So what we could do here is we want to cancel variables. So I want to make this equation here. Let's say I want to cancel 8 over x with an 8 over x, but right now they don't match. So what I'm going to do is I'm going to multiply the first equation by 4/3. Now, the reason I'm choosing 4/3, you'll see in a moment, is that this is going to make 6 over x into 8 over x. So I'm going to go ahead and multiply everything in that first equation in purple by 4/3. Now, if it's not obvious that it makes 8 over x, just know 6 times 4 is 24, divided by 3 is equal to 8. So that's how we're getting, we have 8 over x plus, if we take 4/3 of 6 over y, that's going to make 8 over y equal 4/3. And now what I want to do is I want to subtract the equation in red. So we're going to do minus the equation 8 over x plus 8 over z equals 1. And now 8 over x minus 8 over x is just going to cancel out. This is the elimination here. But now what we're going to have is we're going to have 8 over y minus 8 over z equals 4/3 minus 1 is equal to 1/3. So this equation here we're going to box off because this is going to be important later when we're solving the system. So we already did some algebra involving the first 2 equations, so now we need to involve the third equation. And what I want to do here is I want to multiply the third equation by 2/3. And what this accomplishes, that's going to change the 12 over y into 8 over y to allow us to eliminate more variables. So we have 12 over y plus 12 over z is equal to 1. So we're multiplying this whole equation by 2/3, and you can see here 2 times 24 is 2 times 12 is 24, divided by 3 is 8. So we get 8 over y plus 8 over z equals 2/3. And now what we could do is we could subtract this equation in black here. So we have minus the equation that we have over here. We have 8 over y minus 8 over z is equal to 1/3. And when we subtract here, 8 over y minus 8 over y is going to cancel. And now we have just one variable left. So we have 8 over z minus negative 8 over z. So we're going to add those together. We're going to have 8 over z plus 8 over z equals 2/3 minus 1/3 is equal to 1/3. So now the rest here is algebra. We could add these two fractions together, and we're going to have 8 over z plus 8 over z is 16 over z and this is equal to 1/3. So then what we could do here is we could cross multiply. We have z times 1 is z equals 16 times 3 is 48. So we solved for one of the variables. Remember, John was z, and this means that John can complete a job by himself in 48 hours. So now the rest of this shouldn't be so bad. We're going to take the z equals 48, and we're going to solve for the other variables. So let's say we want to solve for x next. So we could plug in z equals 48 to this equation, and we'll have 8 over x plus 8 over 48 is equal to 1. So now we could reduce this fraction here. 8 over 48 reduces to 1 over 6. So we have 8 over x plus 1 over 6 is equal to 1. And now we could just subtract 1 over 6 on both sides. And that's going to give us 8 over x equals 5 over 6. So from this step here, there's a few ways to go through with this, but we'll just go ahead and cross multiply. And this is going to make, we'll have 5x is equal to 48. And if we divide both sides by 5, we're going to have x equals 5 goes into 48 9 times with the remainder of 3, and 3/5 is equal to 0.6. So what this tells us is that Bruce could complete the job by himself in 9.6 hours. Now we could also use this equation in blue to solve for the last variable y. So what we have here is we have 12 over y plus 12 over z was equal to 48 is equal to 1. So now to solve this, we could reduce 12 over 48 is 1/4. So we have 12 over y plus 1/4 is equal to 1. And if we subtract 1/4 on both sides, this is going to give us 12 over y is equal to 3 over 4. So now we just cross multiply here, and this is going to give us 3 times y equals 48, and that tells us that y is equal to 16. And that tells us Roy can complete the job by himself in 16 hours. So now let's write our answer out formally. Okay, well, this is going to wrap up this 1950s math question. If you think that high school math has gotten easier, please let me know in the comments section below. If you disagree, also let me know that in the comments section below. But either way, thank you for watching.